The error code H5 in GRE air conditioners indicates that the Intelligent Power Module, IPM, has entered protection mode due to potential issues related to the amount of electricity or its temperature. The IPM module, located on the external electronic board, is responsible for supplying and controlling electricity directly to the inverter compressor of the GRE unit. In this video, we will go over the procedures to resolve the H5 error code in GRE air conditioners, starting with the simplest strategies and progressing to more complex ones. As a final recommendation, before intervening with the external unit's electronic board to search for component failures, it is highly advisable to visually check if the heat exchanger or fins of the IPM module are in the correct position and to check the condition of the thermal paste. This is important because loose fins can hinder heat dissipation, increasing the temperature of the electronic module and triggering the H5 error code. Some recommendations to resolve this fault code are: 1. Disconnect the equipment from the power supply for several minutes. 2. Reconnect the equipment and see if the error disappears. 3. If the error persists, check with a multimeter if the power supply voltage is normal. 4. A current consumption above normal can be related to electrical connection issues or loose contacts. You should check the condition of all cables. 5. Additionally, problems with the outdoor unit fan or lack of cleaning of the outdoor unit heat exchanger can cause system overpressure and excessive current consumption. Check the fan and clean it if necessary. 6. Electrical problems with the compressor can cause overcurrent consumption. Disconnect the compressor and, using a multimeter on the ohm scale, measure the electrical resistance between the pairs of pins on the compressor connector. All obtained values should be equal and should never read infinity. 7. Measure the electrical resistance between each pin and the compressor casing using the megohm scale. It should never show an electrical resistance value. It should always read infinity. This rules out current leakage to the ground. 8. Now, let's focus on the electronic controller of the outdoor unit. Check if its indicator LEDs light up or blink. 9. If the LEDs light up or blink, it can indicate that the board is generating DC voltage, and it is advisable to focus on the IPM circuit, which is responsible for distributing this generated voltage. If no LEDs light up, it is advisable to focus the inspection on the PFC voltage generation circuit. 10. When the LEDs do not light up, to check the PFC circuit, ensure that the DC voltage appears within the board, especially the voltage at the output of the PFC rectifier bridge. When the equipment is powered by 110 volts AC after the rectifier bridge, the voltage should be around 150 volts DC, and when the equipment is powered by 220 volts AC after the rectifier bridge, it should be around 300 volts DC. 11. If the DC voltage after the rectifier bridge is correct, now, without energizing the board, check for electrical continuity between the input and output of the PFC circuit coil or reactor. 12. Check the correct resistance values present in the PFC circuit as well as the state of the diode, and, of course, visually inspect and test the capacitors with a capacitance meter in addition to checking for electrical continuity in the board tracks. 13. Check the condition of the IGBT transistor in the PFC circuit. Before checking the electrical status of the IPM, it is recommended to verify if the heat exchanger or fins are in the correct position and to check the condition of the thermal paste. This is important because loose fins will impede heat dissipation, increasing the temperature of the electronic module and generating the error code. To verify the IPM electronic module, follow these steps. 1. Disconnect the equipment from the power supply. Remember that capacitors can store current. Use a multimeter on the DC voltage scale to measure across the capacitors and ensure they are discharged. 2. Locate the IPM electronic circuit. The IPM electronic circuit is covered by heat dissipating fins. Its pins are connected via 3 independent tracks and an electrical connector to the 3 compressor pins. 3. Positive power supply. Identify the high voltage positive power supply of the IPM electronic circuit by tracing the positive track from the largest high voltage capacitors to the IPM electronic circuit. 4. Negative power supply. Identify the negative track from the capacitors to the IPM electronic circuit by tracing the negative track from the largest high voltage capacitors to the IPM electronic circuit. 5. Identify the output points U, V, W. These can be identified by following the tracks from the compressor connectors to the IPM electronic circuit. 6. Set the multimeter to the diode scale. 7. The IPM electronic circuit is internally composed of 6 IGBT transistors, each containing a diode that we will test. Let's start with the integrity test of the first 3 diodes. A. Place the black probe of the multimeter on the positive input of the IPM electronic circuit. B. Use the red probe to measure the points U, V, W. C. The minimum voltage activation values should be around 0.45 volts for each measurement. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading. Let's proceed with the integrity test of the last 3 diodes. A. Place the red probe of the multimeter on the negative input of the IPM electronic circuit. B. Use the black probe to measure the points U, V, W. C. The minimum voltage activation values should be similar to those obtained previously. D. The measurement obtained between the negative supply and each pin U, V, W should yield practically the same reading.